Okay, any announcements? I will point out that the abstract submissions are open for the HamSCI conference. And there is a very nice website up. Okay. I don't see John Gibbons. So we'll kick off with Kung. Any updates?
School just got started back, so I'm
That
being
can
back
be
on
your
the project.
Yeah.
So yeah.
Can I ask if someone can give a short talk about the relation between software engineering and HamSCI? How can we use SWE in HamSCI? I would be thankful if someone can do it. Would be very useful.
Rachel, Bill here. I'd like to give a short update on the status of the importation of historical data into personal space with a station network. Only take a couple minutes.
Okay. If Kung has nothing else, then you are next on the docket.
I was just gonna mention I'm adding solar context to the plots I've been generating, so it has more information on the plot basically. Besides that, yeah, there's no real difference.
Kamal, would it be possible to mute your mic when you're not speaking? Thank you. Okay. Bill, do you want to start your update?
Okay, I don't remember how much of this I talked about last week on this conference, but I have a function running that is able to do with Grape 1 legacy data. It works very much the same as the process for inbounding Grape 1 DRF data, and that there's a couple of different ways it can be used. For the Grape systems, we'll eventually want to add a function, a little uploader that'll run once a day, and we can leave everything else as it is if we want, which will upload the previous day's observation. And the way it works is you upload the observation to your account on our system, and then you create a trigger directory. This trigger directory, it's a directory simply. That was the quickest, easiest way to do it. There's nothing contained in this directory, but the way it works is there is a watchdog on the system that watches for these. Each one has a first character that indicates what type it is. The Grape 1 legacy system, you'll create a lowercase g as the first character of the trigger directory, and then it contains some other information like the name of the observation and the instrument number. It's an uppercase G for Grape 2 stations. I haven't gotten any data to work with on that, so I haven't tested that, but I have it working. Now, for importation of the historical data, I can create the files manually, and then I can create the trigger files manually, and they will go into the system. When the system notices one of these trigger directories, it will take a look at the metadata regarding that observation. We do one observation at a time, and then it will add the metadata to the personal space with a station network database, and it will show up as an observation, and it will run a plot. So I'm running plots on the historical data for Grape 1 legacy systems, similar to, well, it's the same plot as the software. It was created by Christina and Nathaniel, and there was several other authors that I don't remember anyway. it creates that same plot. Now I'll show you what it looks like. And there's also another function where you can get to it through the map. There's two ways to get to this data. Let me see if I can, okay, somebody else is sharing. Could I get, okay, all right, let's see if we can share this. Okay, here it is. I suppose everybody has seen this map. This map is available even if you're not logged in. And if you, this is a typical view you get. So if there's a station you're interested in geographic location, you can zoom into it and click on it. And this is Veronica's station, KD2UHN. Obviously, she's at Virginia Tech now. She's no longer running the station, but we'll have all the historical data for everybody. And click on that, and you'll get that person's observations. You can sort it different ways. Another way you can get to it is if you go to observations, and then here you click on Grape 1 Legacy and do a filter, and you'll see all the Grape 1 Legacy observations. So if there's a green ball next to the observation, that means there's a plot available. And when you hit this, you'll get this plot. The Doppler shift is on top, and the peak voltage is on the bottom. It's similar to the spectrogram and amplitude plots that come with the Grape 1 DRF. And so it's possible to download this plot. If you want a clean version of this plot as a file, you'll get the PNG file. It downloads it to you right there. Or you can download the entire observation, and it will shoot it into your download folder, and you can play with it yourself. So,
Bill, a quick question.
yes.
Would it be possible to plot the amplitude in dB rather than in raw voltage?
That is something that's beyond my skill level with this software. I'll give that request to Nathaniel or Christina, and I will work with them on an updated version of this.
Yeah, very good.
This is between the skills required and the time required. I can't do that. It's doable by somebody who has the skills and the time, but I don't know if anybody who has the skills also has the time right now. I mean, we can put that down as a request for the future. And
okay, thank you.
That would help a lot. One thing I should also mention, and I had this online email discussion with John. John knows what I'm talking about here. If you take a look at the way down here, let me see. Here we go. Take a look at right here. The node number has a 7-digit number in it. And then in this case, there's 5 zeros and a 1 5. That is different from the node numbers on the personal space with a station network, because I could support only 6 digits total. So there's 4 zeros and a 1 5. So I've got it set up. All the standard on the Grape 1 legacy system is a 7-digit number there. The standard on the personal space weather station is a 6-digit number there. This is a misunderstanding on my part, I suppose, from 5 years ago when we were in a panic to get everything ready for the eclipse and etc. So I support this now. We'll stick with the 7-digit standard. It's just I'm going to drop that first 0 when it comes into the personal space weather station network. John and I had this discussion. So far, we haven't been able to think of any major negative consequences from this, other than maybe a little confusion, but we just have to publicize this. That first character, to my knowledge, to our knowledge, isn't used for anything. You can still support millions of stations, because this layout as it is will still support 999,999 stations. Plus, there's nothing says that first character has to be an N. That first character can be anything. The standard on the Grape 1 DRF systems is that first character is an S. I changed that I was going to use N's, but then I changed that to an S for the Grape 1 DRF DRF stations, so that we could have two stations could have a 15, rather a node number between the two different station types, and they wouldn't conflict. And so, anyway, the only thing is, if we're going to use that first character, we can't use it for any metadata. Now, the fourth character from the thousands digit indicates whether it's a grape 1 or a grape 2. So those stations that are grape 2, it'll be N and then a number, but in the thousands digits, there's a 1. That's the current convention, and this will support that as well. Okay, so anyway, that's all I had. Back to Ned.
That's a lot of good work, Bill. That's phew. You've been burning the midnight oil.
Oh yeah, this I've been wanting to show this because this was very difficult to get working, especially getting the plotting working, because you know it's old code that I never had a hand in writing, so I had to figure out how a lot of things worked to retrofit that to this.
Yeah.
So, also, you'll notice that I am storing these files as CSVs rather than as zips, and there is a reason for that. Eventually, we're going to support a happy server on this box, and though happy servers depend on there being a CSV there and not a zip file. So anyway, step by step, we're getting there. And by the way, I will be going to the COSPAR International Space Weather Action Team meeting in Cape Canaveral, second week of February. We'll be presenting this as well as the Madrigal solution to the International Space Weather Action Team. I've met with that team in a couple of different international locations, and this year happens to be in the U.S., which is nice. Last year I turned it down because they wanted me to go to Korea, and I said that's too much, but maybe next time. So anyway, back to Ned.
I think that looks phenomenal.
Yeah, I agree. Bill, I am so glad that you have done this. And I know this is a really important item for the whole GRAPE project, because it really makes sure that the data that's been collected with those systems so far is going to remain accessible and usable. So it's just a tremendous thing. Thank you so much.
You're welcome. We are working on an analysis. There's an analysis tab, and we're putting the final touches on the magnetometer analyzer. But I can foresee that we might want to add that that function that this plotting package does. That's the red, white, and blue plot that shows the annual variation in Doppler shift. That's something that I know Christina worked on that a lot. I don't know who else was the authors of it, but that's a pretty cool thing. That's above what I could accomplish for right now, but we do have funding, and there is a section in DASI 2 to add a number of analysis functions, and if there's a demand for that, we can add that to this as well, I think. So anyway, back to Ned.
I think so. One thing I'd like to have either add to the agenda or we can discuss now is I know we have what we wrote in the proposal for DAISY 2, but that was about a year ago. I want to make sure that we all really we know and understand the scope of work that we're going to have Bill and the University of Alabama do, and I want to make sure that Bill and the University of Alabama are comfortable with the scope of work everyone's expecting. So I think what I propose is that we have some, on this telecon, we have some discussion about what the scope of work would be. And the way I'm imagining this would go is that Bill you would put together a presentation that you would give that would basically outline what you're planning on doing and how you're planning on doing it, what features are going to be added and things like that. And then there'd be some time that we on the telecon would be able to give you feedback, and we iterate on that back and forth until we are all happy with the features that would be added and you're happy with the scope and how you can handle it. Bill, does that sound like an appropriate method, or do you have another suggestion?
No, that's what we need to do. And I have a meeting with Dr. Atkinson on Monday to talk about what amount of manpower we have available from CAPS, which is Center for Advanced Public Safety. As I recall, we did put some funding in here for 1 or 2 professional developers part-time, but these are folks with 10, 20 years of experience and they're full-time. I mean, students are great, but because of their class load, they can only put a few hours a week into this. We do have access to staff from CAPS that can put in 40 hours a week, and people who they don't even have to look stuff up on the web. They know what is, how to do everything right off the top of their head, and it just zoom through getting development done. So once I'm going to find out what availability we have for that labor pool, and then we'll block out block tasks for them to do. And with that, you got to be a little bit judicious in how you use that, because if you hadn't, what would you say, haven't properly outlined what you want, they'll produce something that's wonderful and elegant, but it's not what you want. So it's perfect that we schedule that for whenever we can. But remember, I still have to put together the presentation for ISWAT 2, and I'm also working on importing the 66,000 files, and that's not all of them. That's a snapshot as of the end of October, and there's been months of observations since. So it's not hard to get the stuff. It's just that you have to do it. So anyway.
Well, I think that's good, and we certainly do. I think as long as we know that's on the plate and that's something we really need to do, is work out all of that planning for this. There certainly are other things that we need to continue to do on this telecon before we fully move out of this just the Grape 2 telecon that we'll also need to spend time on. That includes like making sure we get the full data sets back from all the Grape 2 people, which Cone can talk about, and there are other things as well. And we need to make sure we get Christina involved in this as well. I think, David, did you say Christina's not available this week?
Yeah, that's correct.
Yeah. So I'll have to get in touch with Christina because I know she's eventually going to start coming to these telecons, but I know she's also transitioning from, wrapping up one postdoc project or something, and then before this one fully starts on. So we'll have to make sure that Christina is actively involved in this development as well. But I think if we get this plan all worked out first, and then we, like you said, then we have them actually do the tasks, I think that will be best. Go ahead, Rachel.
Okay. So I'll just put that on sometime in the future.
Yeah,
We'll say-
sometime within the next 2 weeks, if we can, because
Okay.
if we have developers associated, rather assigned to this, we need to start using them. So
Okay.
And
Well,
and Bill,
I
yeah.
swap. Assume that's maybe in 2 weeks. I'll add it to the agenda then. To at least check in.
Bill, would you be able to reach out to Christina too and start coordinating with her? Because I think we really need at least 2 presentations here. One from you regarding the Alabama work plan, and one from Christina regarding being the chief operations scientist and what that entails from her. And I see Alabama and Christina working closely together because I imagine that for her to do her job as chief operations scientist, she's going to need certain tools from the website to help her do her job.
Yeah, I'll contact. I'll let her know what we have in mind and see. I'm sure she's another one of those folks who is oversubscribed chronically. So, but got to fit it in somewhere. But this is part of her funding, though, isn't it, too? So she should be able to justify.
Oh yeah, yeah. This is paying like 30% of her salary or something.
Okay, I'll remind her of that if I have to.
You won't have to push hard. She knows. But
I know. I'm just being silly.
She would enjoy that.
Yeah.
Okay. Any other questions, comments, or concerns about that? Okay. Okay. Any updates on the grape antenna project? Let me check if Rob is on. Any updates from you, Rob, either on the
Hold on. Okay, I just had to get my mic down and the microphone on. Yes, we're there's a lot of work going on between Glenn and Elmer and 3AGC, AGE, and to refine the Elmer's site is a particularly challenging one that perhaps may not be. Hopefully, we won't. I don't think we'll want to have any sites like his. He's on Long Island, and it turns out all these AM broadcast stations. They're 50 kilowatt broadcast stations right across the water from him. He's right next to the water. So he's been on a 6-meter dipole, which is kind of the one that's sensitive to ITU at 10 meters. He was getting a volt and a half off the antenna, peak voltage. And the solution is pretty straightforward. Shorten the dipole. Instead of 6 meters, make it 3 meters. But through this process, we've identified one criteria that we need to use at sites is at DAISY 2 sites is that we need to know what the peak voltages are at the antennas. If you have, it's not just AM stations. FM stations are a tremendous source of problems for active antennas of any sort, whether it's the single antenna of Glenn's or the DX engineering, and identifying when your reception is impaired by local broadcast stations, whether AM or FM, is an important element in the evaluation and monitoring of any one of our sites. So there's progress being made on this. Just the site evaluation, which is to me the most important part of what we're doing. The single antenna is, when appropriately run, remarkable. It is truly remarkable that you can see the noise floor in the presence of now half a volt on the antenna terminals, and there's extraordinarily good common mode rejection. So local the QRN that we're seeing and RFI are seeing is truly differential. So there's many good things about it. I'm not saying that it's the antenna will choose, but we do have techniques in place, and there's a lot of action. I mean, we're also refining, learning problems about the K9Q software or the way we're using it. Turns out there's we need to, and Phil has already implemented a second stage of filtering to enable a further refinement of frequency discrimination. The single pass of FFT right now, in the presence of very strong signals, they spread out in the receive bandwidth. They're not spreading out elsewhere, but we've again identified that. Phil has implemented a secondary filter, which I'm about to try today. So the whole receive system is, in very, very active, both hardware and software of the whole end-to-end receive system is under very active development by Glenn, Elmer, Franco, Phil, and me to some extent. And I think we're close within a short period of time. I think we will have the finalized values for the single antenna, and we'll be able to. We do have. Glenn has 4 additional alpha test sites that will be. We expect in the next few weeks will go up. So we should have maybe by the by the end, by a month from now, I'm hoping we'll have 5 sites running this software and candidate receivers. I forgot to mention Michael, of course. Michael Howland is a key part of this. So that's the major things that I can report about our activities. Very busy in the background. And there's Michael. So I don't know if there's anything I missed, Michael, let me know.
If I can share the screen, I can show you what the DX Engineering antenna and the single antenna site look like from my site. Let's see here. I want to share.
Share button is on the bottom of the Zoom call. It's our bottom.
Yeah. I just have to get over there. Boom. Can you see that?
Yes, we sure do.
So on the top, you see that's the DX Engineering. And so some of the things we're looking at, as Rob already explained, are the noise floor. It's also important to look at what the spectrum might be telling us about local sources of noise. And you can see that in here, some of these little lumps of and bumps probably correspond to some local noise. Out here, it's looking pretty nice, though. I've found that one source of local noise that's fairly easy to mitigate are the tiny switched power supplies that are used to power things like Raspberry Pis, network switches, and things like that. If you can't actually switch them to true DC source like a battery, if in one case, a Raspberry Pi switched power supply that I was using, I just wrapped it in a bunch of turns of a toroid because I didn't have a DC source immediately available, and that seemed to mitigate the noise. But one of the objectives among many is to try to make this as flat as possible. Glenn's observation is generally, and this is in line, of course, with the ITU noise figures, it should be a gradually downward sloping curve that suggests where the noise floor is, and anything that seems to interfere with that is going to be a suspect area for noise. So
you might notice that right below 12, about 11 megahertz, there's a burst of noise appearing on the DX Engineering, which is much less prominent on the single antenna.
Linear supplies work well too.
Yes, if you can find them, the heavier regular linear transformer based power supplies are going to be more quiet than these little switched ones. And frankly, I had a couple that had the same distributor's name on them, but one was noisy and one wasn't. Not of the transformer type, but the switch type. You know, the ones that you get when you buy a Raspberry Pi, for instance. Now, some of them are quiet, some of them are not. You just have to find out. Anyway, that's
Yeah.
The beauty of the spectrum is nice.
It would be good if we identified specific makes that are quiet, because switching supplies can be quiet, but they have to put the components in.
Right.
And a lot of
Right.
times they just leave them out. They're actually spots on the PC board.
I've had
Yeah,
I've had pretty good luck with the chargers that come with cell phones. Samsung seem to be reasonably quiet.
That's a good point.
yeah. The I've used extensively, and many of us have used the Meanwell brand, which Meanwell is a Taiwanese manufacturer, and their supply, they have a wide range of open frame, all USB output, all kinds of stuff, and they're both very quiet and not too expensive, easily available from Jameco and other um, digit.
Yeah,
Yeah.
they are a reputable brand.
Yeah, but even so, there are times when what you really need to do is, Clint, KA70EI has documented this, that how you can suppress the emissions from any switching supply if you properly filter the inputs and outputs. Both, you have to filter on both sides with something like a line filter like the Corcoms, the 110 volt line or 220 line filter. So you can, if you use those and put a switcher in a box, you can get them to be as quiet as a DC supply. But they're not, no, they don't make them in that form. There's, the switcher manufacturers. So you have to actually build one. You have to take a Meanwell, put it in a box, get a couple of Corcoms from, wherever, and then, wire it all up. And that's a lot of trouble. But I think for our sites, it's, one of the hopes was we could run everything off of 12 volts or off of, 12 volts. And but then you have to switch, you have to change down to 5 volts for some. If we were to use the Orange Pi, we'd have to go to 5 volts to a USB input. If we use the B-Links, what, 19 volts? So either you have to step up the 12 volts. I mean, so that means that what, irrespective of what antenna we use, we probably are going to have to come up with a power supply for the Daisy 2 installations and include the power supply as part of it. I don't know.
I will say that this antenna, the DX Engineering antenna, and if everybody doesn't already know this, this is the one that at least nominally Nathaniel wrote into the grant, performs very well with whisper decodes and in recording WWV tracings and that sort of thing. As a matter of fact, it actually, I have an antenna here, which is a 200-foot, three-legged terminated folded dipole, which has generally been my best antenna. But the DX Engineering has recently been rivaling and even exceeding the number of whisper spots.
Of course, the
reported.
dipole's got nulls that DX
True.
doesn't.
Well, and so
vertical versus horizontal.
Some of the work that Glenn is doing, obviously is developing some of his goals. Ultimately, we will have to determine whether the Daisy goals are how either one of these antennas match the Daisy goals. One important one, of course, is going to be the ease of installation and maintenance. This is the DX Engineering antenna is a commercially produced product. It does require a little bit of mechanical assembly when you get it, which is important. It does require a little extra equipment to buy because you need 75 ohm coax to run from your shack out to wherever you've pounded it into the ground. It requires a ground rod that you have to provide to attach it to. So those are practical features of installation and maintenance that we have to evaluate.
Does it use F connectors or BNC?
Yes. F.
It does use F.
Yes.
Oh, okay. Yeah, because 75 ohm isn't required, but they use it because it's cheap and available.
Right.
And this burst at 11 megahertz is really quite curious in the fact that the DX Engineering is picking up So such a loud signal, and the other one is, quite quite lower, quite a bit lower. Have you tried to figure out where that's coming from?
I'm trying to get this. There we go. Zoom. I'm hitting the wrong button. That's why. Let's see. Auto scale. That's it. And a little bit of
Yeah.
a closer view. I can't tell you what that is. It looks organized. Let me try to
one of
zoom
the-
in this same area.
Yeah, one of the things you
on
might
this one.
note is that this spectrum display that Scott has created for us has a very rapid update rate, 10 hertz update rate. So
Right.
you get to see phenomenon with this that you really don't see on other SDR console displays. So his work has made a major contribution to our understanding of RFI sources and ability to observe them. But yeah, that's something that
They're
those
still
birds,
there.
yeah.
It's
They
there,
are
but
still
it's
there in
much
both.
reduced
They're
in the
just
other antenna, and I
much-
presume that they're very close together. So I wonder if it's something that's actually in the antennas.
It's ground loop, and it's ground loop induced. That because the
But
DX
it's
engineering is an unbalanced antenna, the
Yeah.
ground is part of the
Oh,
antenna,
that's a good point.
and so
But
this is
It must be local.
I would
And
think
then you
that
see
you
these
might be
things
able
here,
to.
too.
I think that some kind of a if you had a Michael, do you have a blocking transformer T11 in the DX engineering feed line?
No.
Do- Yeah, you might.
No,
That might help. You might try that out and see if the T11 eliminates that. It may not. It may make it worse for all I know, but it is one way to ensure that what you're seeing on the DX engineering feed truly is differential. And you might put a T11 at each end of the coax. Yeah, it's
Is
Well,
the
one of the
DX
things
engineering
that's-
powered through the coax?
Yes.
yeah.
Okay, so that makes it difficult to put the transformer in it.
Oh yes, of course. Well, the DX engineering
Both of them are.
has a separate it has a separate option to supply the DC separately. So one thing you
Right.
might do
Sure.
is
That
to
might
go
be
out
a
and
thing to
go
try.
out and
Turn-
battery power the DX engineering and
Turn the-
see if this phenomenon goes away. We're
Turn
going
the
into this.
transformer. Turn the transformer 90 degrees and use it as a common mode choke.
Well, that's what we're talking about. Is well.
Well, yeah. Or just, make a common mode choke, which I do all the time with ferrite rings.
Well, one of the things
but-
that's
yeah.
fascinating about this
Good point.
is not just the mitigation, because of course I want to try to mitigate this, but I think there would be some merit in actually recording some of these things so that we develop some pattern recognition to advise people on the way some of these noise sources can show up in the spectrum, and so help you more rapidly identify them and look for
Right.
them locally, so that a catalog really of some of the appearance of these noise sources on the K9Q web spectrum like this, I think would be a pretty useful knowledge base for anybody who wants to put one of these things up and use any antenna for that matter, and use
Michael-
this software.
Michael, do you have any 140 or 240 toroids?
Yes.
Because if you just wrap a bunch of 316 or 174 around that, pretty much of any mix, but like a 43 or
As part of my
61,
efforts, I just ordered several of those from Palomar
Oh, okay.
Engineering, and so I'm going to start wrapping some stuff up and see what effect it has.
Yeah, because we use those all the time.
Well, one thing to Michael's, I would try battery powering the DX engineering. That would allow you to eliminate the.
It already does.
Oh, it's
I
already.
switched them both to battery. They're both being powered by battery. both these.
Oh,
antennas.
okay.
Okay. I
Oh,
would
and then
expect.
then you
I-
can put the transformer in the way.
Yeah. Then use a T11 in the feed, and you'll be fine. That'll tell you if the engineering is seeing a differential signal out there, or whether it's a common mode through the ground.
Well, no, so it's not in the. I don't know that I can still put it in the feed line. You know, both the DX engineering antenna and the shack board for the single antenna that
Yeah, you
Glenn
don't
has
need.
made are running power in the feed line. In one case, it's a coax out to the DX engineering, and in the other, it's the
Yeah. But that's completely different.
Ethernet.
Okay, yeah, those aren't comparable to each other. That in the case of the DX engineering, that what I was suggesting is you take battery power and power it out at the antenna, and then introduce the T11 out at the antenna.
Okay.
So they use that if these
I have to
bursts
buy a
dissipate.
separate unit for that.
A separate unit, a separate what?
There's a separate device from. I'll look at it. I can't.
I would think you could just. I thought
think there's a separate way to feed it.
Do try the common mode choke too. That may take care of it
Yeah.
alone.
Yeah. Well, in any case, we can talk about this offline. It's but it's very interesting to see the differences between them. I think that while these specific RFI sources may not be relevant to our measurements and recordings, maybe they're not at WWE frequencies. They demonstrate the vulnerability of these different receive systems to impairments, and since every site is likely to be different, of course will be different in terms of its RFI sources. Trying to understand and eliminate them as much as we can, I think it helps us wherever we go, eliminates that uncertainty and variability.
I'll just point out what I've done here is I've zoomed out to 64 megahertz. The B3 is the single antenna system. Boy, that drops down dramatically. These signals here are aliases.
Because you don't have
from local FM stations, because the DX engineering has no low pass filter in front of it, and neither does does Glenn's system either.
Well, that seems to have a very sharp 30 megahertz roll off.
I know, and this is confusing me. I do not have one of Paul's filters in line in front of this, so I'm kind of fascinated by that. It goes down to here. It's still
cuts out above that very sharply. So there's a filter there somewhere.
I don't think there's a filter
I didn't think I didn't think I don't think that I'm surprised because
that's
I didn't remember that was we have the schematic, so we go look at it, but I haven't looked at Glenn's latest shackboard schematic. It's online, so it's
Well, mainly what I wanted to show, however, was these. These are aliases. I put together a spreadsheet that I can put in I can do two things. One of them is I can put in the frequencies where I see what I suspect is an alias and use that based on the sampling rate to predict what frequency of transmission might be causing the alias. And then the other is I could other way around is to put in the known local FM radio frequencies and then knowing the sampling rate predict where an alias might show up, which is kind of useful when you're looking at one of these things and you see weird signals and you wonder what they are and whether they might be an incursion of an alias. This is definitely an alias from a local FM station, 91.3, I think it is.
And neither of these is overload. Can't see whether the overload counts on your screen, but I assume that neither one of them is.
Here's over ranges here.
So those are
so they're not being over.
So those aliases, it seems, are coming from the active componentry out at the antennas. That suggests that the DX engineering is much more sensitive to overload than the single antenna is. you know, and you're in a semi-rural location, so it's would seem like you would be pretty typical for a Daisy 2 site, and that sensitivity to FM overload definitely it needs to, because you won't see the aliases that propagate down into the shortwave band. They'll be mixed in with all the signals down there. So the fact that you're seeing them above 30 megahertz is a little worrisome. That would we should understand that with the DX engineering. So
Anyway,
as you guys can
that's
see,
kind of where we're at.
yeah, so one of the things that you can see is that while we don't want to look at up at 6 meters, running the 888 at the 129 megasamples seems to really gives us insights into the performance of the receive antenna system that you don't get or get masked if you only look from 0 to 30 megahertz. So. Hopefully that for others who are working with antenna systems, these kinds of observations and measurements would help you with your non-HamSCI work. I mean, this is applicable to every receive system. It's not unique to the DAISY world. I think that's all we had to talk. I mean, I could talk about, we're uploading floats, by the way, and that seems to work perfectly, Bill. I didn't have to do anything. So I have an alpha site, KJ6MKI is uploading, and there too, having a decibel vertical indicators in decibel would be a lot more interesting, but you get good displays. They look very reasonable to me. So I haven't quite finished it, but I'm very close to finishing the Whisper Demon software for all this. Sorry, we really hijacked this meeting on the antennas. Just let you go back to the network unless there are questions.
I think this is excellent work, Rob and Michael. Thank you so much. I don't think this hijacked the meeting at all. I think it's very relevant to what we need to do for this project. So I'm very excited to see the progress that you've made on it. And I don't think we're there yet, but it looks like we're making good progress towards making an educated decision as to which antenna we will actually deploy with the new DAISY 2 project, and probably what we recommend, on our website, what we're going to recommend people use for equipment that they buy themselves.
Well, I believe that Glenn's at the stage is really adjusting the gain component values in the antenna. There's nothing mechanically. They seem to have the enclosures and the clips and identified a vendor for the mast. And Elmer is there on Long Island is definitely doing weather testing. He's got ice and 60-mile-an-hour hurricane winds with sleet and all kinds of stuff. So he's doing a lot of good deployment testing.
Where Elmer is, I'm wondering if that might be a good site to try a loop, because loops have a strong null that can be used. And you also can notch them much more easily than dipole antenna.
Yeah, he's of course there's directional antennas, of course, are helpful, and if you can, he lives on a postage stamp sized lot in right by the water, so his very limited choices in terms of what antenna.
So I'm not talking a big thing. I'm talking a 1 meter
you're talking about the 1
loop.
meter loop. Yeah, they're the problems with I mean, he has tried those, and yeah, there's so many different sources of noise, and the loop antennas, those little loops are, can't reach the ITU limits. Now, it may not be important to reach ITU limits. His RFI environment may be so bad at his location that that limitation of a loop may not be relevant to him. But Elmer's a big experimenter. He'll be trying all kinds of stuff, um, um, and we have four other sites that Washington State. I forget who else
Well,
is it. Michael.
I'm just saying he's got the same sort of situation we have in our research a lot of
Yeah.
having a high power station right next to our antenna, and
Yeah.
we have had to find ways to mitigate that.
Yeah. Well, we're still trying to do Elmer and Glenn are trying to use his site as a way to see how close can you get to ITU rural in a site like his, and they're doing remarkably well. I mean, he's 10 or 20 dB better, less noise across the spectrum than he had when he started. But the I think one of our criteria, I believe, for this is for the DAISY project is an omnidirectional antenna. So, any antenna that has loops in it and so on, the directionality, I think would impair the usefulness or comparability of the reports relative to other the omnidirectional antennas. So, I think, I mean, others, it's not for me to decide what what kind of sites we want to deploy at, but I think we'd want to find
Rob?
ones that we don't need to have loops that null things
Rob?
out. Yes.
The null is at 0 elevation.
Mm-hmm.
So, I mean,
Yeah, with a higher wave angle, it's more omni than you think.
If we're looking for ionospheric signals, and maybe we're not.
That's a good point. Well,
but I mean,
Michael has loops. He's got the LZ1AQ, and I don't know what other loop you have out there, Michael. If you have anything, you guys are talking about
delta loop.
Yeah,
the LZ1AQ. I have an LZ1AQ that I have two. I have the one that David actually recommended, which was a variant of the original, produced by what was it, N2NY? I can't remember the call.
N4CY.
N4CY. And then I have the original Bulgarian version, which I'm assembling right now, which also uses a couple of loops as a dipole, or you can turn them orthogonally. So
I think
I should have that assembled pretty soon. And
yeah,
be able
David,
to
I think David and Bob are suggesting, I think is mounting them horizontally so that did I get that right?
No,
no,
but also, but as Michael points out, the LZ antenna actually has two loops, crossed loops. So you can get around the omni question that way. There are various ways of using that one.
Michael, you're muted.
There's two ways to do it. One is to have them as a dipole, and then the other is actually have them superimposed so that they're kind of in the same, make a sphere.
Yeah, you can impose a 90-degree phase shift and make it sensitive to all directions. And there are a lot of different ways you can work that one. But yeah, a vertical loop, yeah, it's got a plane that's got a strong null, but it very quickly disappears as you go off that plane.
Well, anyway, I think even DX Engineering offers loop antennas. So if we wanted to compare it, I think it would be, I think I don't know. My understanding is we're looking for quiet sites where such nulling of noise sources wouldn't
Well,
be
that-
necessary.
Yeah.
So,
So yeah. So actually, now that I think about it, yeah, a loop is different than a dipole in a sense that, well, no, not really, but there's a strong null at 0, but then it has response all the way around
Yeah.
otherwise.
its vertical response is very good.
Right. And I'm looking
and
to use that for vertical signals, which the vertical dipole is not going to work for. It has a null at the zenith.
yeah.
well, okay. I mean, it's up to I don't know that we, apart from the LZ loop and that other one, I don't know that are they part of Michael? Are they part of your regular evaluation process, or should we add them? I can send you more triple eights, if you want.
As he says, he has 2 of these.
Yeah, I
I
have
know,
a
I see.
DX Engineering, I have Glenn's SA system, and I have a LZ1AQ. The LZ1AQ is not currently deployed, but will be deployed shortly. So we'll be
And
able to compare all 3.
And you have the N4CY one.
It's now 11 a.m.
Yeah.
Eastern, so I suggest that we conclude the formal meeting now. And anyone who would like to stay on and continue chatting, they are more than welcome to. But I might turn it over to Rachel to wrap things up and let us know what we should expect for next week. And also,
I do have a question for the group once we,
hold on.
not part of the formal meeting.
Okay. And so David wants something for not part of the formal meeting. And don't forget, this afternoon at 4 p.m. Eastern, we have the Ham Science Telecon. Gary, do you want to say anything about that really quickly? I think you're muted. Gary, I think you're muted.
How's that better?
Much better.
Yeah.
Sorry about that. Yeah, Diego Sanchez from University of Scranton, formerly NJIT, right? We'll be talking, giving his presentation that he gave, I think, both at AGU and at CDAR about 14 megahertz amateur signals and looking for LSTID signatures and stuff in it. So right up our alley. And be good to support one of our graduate students as well.
Yes, absolutely.
I
Yes,
have
4 p.m. Eastern today.
I have a quick photo to show. Let me share my screen. Be on there for 10 seconds. Oh, where is it? Share. There we go. You got it? Loop antenna.
Very nice.
Okay, works great. It's less than a meter in diameter. It uses the electronics from an M1 over in England. Thank you much.
Rachel, would you like to wrap things up?
I don't think we have any other business unless anyone has any updates, questions, comments, or concerns.
Rachel, is your schedule freed up a little bit? I know the first couple of weeks you had qualifiers and stuff. That's why I kind of grabbed the ring on putting the announcements and stuff. I want to go back to doing that, or what should we do?
I will probably start making some announcement emails again because
Okay, that's fine.
Okay. Any other questions, comments, or concerns? All right, that's it. 73, everyone.
73, everyone. Thank you.
I've got a question for the group. We have very strong interference at South Pole at very specifically 2.48 megahertz. And we can't figure out where it's coming from, but it's so strong that it's blocking one of our channels. We've got cross loops and large cross loops. They're 20 feet on a side. And one apparently is somewhat nulled, but it's a very strong signal into that one. And then the other one, it's so strong that it's blocking our channel. Because when the signal turns off, which it used to, now it's continuous, when it used to turn off, we'd get our signal back. But we have no idea of what would be at 2.48 megahertz.
Does it have modulation of any kind?
It has some, it seems to be noise. Yes, it has some kind, it has breadth, but we've tried plotting it and it really doesn't seem to, I can't, it may be amplitude modulated, we're not sure. It's certainly not sideband.
Build an adcock antenna and see if you can.
I'm not going to be able to do that at South Pole.
Well, it's summer down there.
Right, which is also part of the puzzle, because 2.48, 2.5 megahertz shouldn't be propagating very well. So we figure it's got to be something local, but we have no idea what could be generating it. And I don't think we have any general coverage receivers down at South Pole at the moment. Though I've been thinking of having someone go over to the ham station and see if they can tune it in.
Well, somebody must have some kind of direction finding things, I think, at the South Pole.
No, they don't. We are the ones.
I'll take something down.
I've done that, but I'm not there, and it's very difficult to get there these days. So I just wanted to see if anyone had some bright ideas of what could be. I was thinking maybe they've got a data link or something at 2.48.
There must be other stations on the continent, the South America,
Antarctica. Oh yeah, there are lots of stations.
But are they hearing it? That was
we don't know. We don't have real contact with. And I don't suppose there's a Kiwi or something at McMurdo yet.
I just looked on my spectrums on several different antennas. I see no signal on that frequency.
Right. I certainly don't hear it up here.
David, we're going to be working on, hopefully, putting one of these Whisper Demon RX 888s down in McMurdo. But of course, that's going to take quite a bit of coordination. And
that'll be a while.
And yeah, well, the hope, I think the hope is that we have it ready to ship for this field season. And the hope is that the research associate down there can install it. I actually have sitting in my email boxes emails from Veloja and from Jim LaBelle starting to talk about this coordination. So I guess, but that's very interesting to hear about that. And I guess we'll find out
it's something that just showed up this fall, apparently.
Yeah.
And
unwrap a coat hanger and make a loop.
I need to
go. If it's strong, you ought to be able to find a null.
And
yeah, well, we